Hello everybody, today we'll be doing reverse a doubly linked list. Given a doubly linked list containing n nodes, the problem is to reverse every pod of k nodes in the list. So here's an example. We have 1 through 8 and we have k equals 3, that's the size of our pod. And so we need to reverse every 3 items. So 1, 2, 3 becomes 3, 2, 1, which points to 6, 5, 4, which points to 8 and 7. Let's get some edge cases here, and we'll be figuring out how to implement this afterwards. So edge case, one thing to think about is to have a k of 0. So what would that look like? I think a k of 0 would mean that basically the whole thing is reversed. And what if we have an item of negative value? What if we have something that's going to, we want to set this as what about that? What do we do then, right? How do we deal with that? So I think, let's say it becomes negative 1 pod. I think maybe we should just return a none and do nothing. Just do nothing. Flat out do nothing. Return none. Just give them none. I think that's fine. And if we've messed around with all the k items, right, we should mess around with the input. So the input, let's see, what could the input be? Let's say an empty input and a regular output of 0, 10, whatever, it doesn't matter. Over, if it goes over, that means we still have to reverse the whole thing. 0 or more than, actually 0, maybe we shouldn't, we should reverse, there are no pods, or more than the size of the linked list. Reverse everything. And let's see, if k is 10 or less, what does that mean? I meant back here at k equals, doesn't matter what it is, but we're looking at a empty out input, so we're just going to return an empty, because doesn't matter what the pod is. Doesn't matter. Okay, so those are edge cases. Let's get to matching. So matching is that I see that we have to create a doubly linked list. We're doing linked lists. And we're doing pointers. We are doing pointers. So we have to reverse the whole linked list first and then figure out how to do pods. So in this part of the problem, this is part 1. What we're gonna do is just reverse the linked list, doubly linked list. So reverse doubly linked list. And you can see that this is much more difficult than reverse a singly linked list because there are previous pointers. And so let's do that. Then reverse by pod. Okay, let's implement. So how do we do a reverse linked list? Well, let's think about it a little bit. So we create a dummy node, create a previous node, a current node, and while current, point current to previous, right? And point current dot next to previous. and point previous dot previous to current. That way, we're able to point our items from the most recent item. That next item will point this way towards the 1, and the previous will point the other way. And that way, if we go through the entirety of the linked list, we should have a pretty solid result. And let's check out what happens there first, as we get more information before we start implementing. As I said, this is not an easy problem to do because of all the pointers, and it's definitely not the easiest thing to think about. So we have our inputs. Let's say we have our previous, we have our dummy node, and that points straight to 1. So previous and current. So what happens is that we want to point our current node, current.next, so that disappears. So we'll also have to create a next node. Okay, so we create a next node, my bad. And let's point the current.next to previous. So 1 now points, current.next is 2, points to 1. Right? So, I mean 1 points to D, the dummy node. So 1 points to D, and the previous dot previous. So D points back at 1 as its previous item. Great. With that, we are ready to continue, right? And we set then point previous to current and point current to next, right? And that way we can go. So current.next is going to be 2, will point to 1, and previous, so 1, 2.previous, that pointer disappears and points back at well, actually that pointer doesn't disappear yet. My bad. Well, the 1 pointer that was supposed to be here will point back at 2. Let's move on to the next one and check that one out. So now, current is 3. So 3.next is going to be like 2. And this was pointing to none, of course. Like, yeah. And 3, 2 previous was pointing to 1, right? Now, 2 previous is going to point at 3. So this disappears. And now we're left with, we move everything forward, and we're left with a previous that dot next is pointing to none. And wait, that next is going to be pointing to 2 already, sorry. So we have a previous that has a previous pointer back to 3. So that means that we have to remove the that means we have to remove the previous pointer from pointing to previous. There should be nothing from the previous. Maybe we should set this way. We should say head is equal to previous. Remove previous pointer from head, because there should not be a previous pointer from head. So now let's say we remove this pointer. What do we have? So now we have this picture, but we still have the dummy node pointing to the 1. So we need to also remove that. So remove dummy node dot next. So dummy node is now none. So that pointer disappears. But we also have a pointer from the dummy node back at the 1 right now. Right? So dummy node dot previous, remove dummy node dot previous dot next is equal to now none. So dummy node dot previous dot next is none, and dummy node dot previous is none. So that eliminates that pointing system here. That we no longer point, 1 no longer points at D, and now we have reversed the doubly linked list here, and we can output it. Okay, with that, I think we have a way of doing this problem. So let's start off by defining that function. Well, there is one thing that we have to do first, is that we have to create a doubly linked list first. So this is basically like 3 problems in one, so that's why it's going to be so long. We have to split up this problem into several videos. So let's create that class as linked list node. This is a pretty long name. And let's define the init function. Val, next node is equal to, or let's just call it next is equal to none. And prev is equal to none. And so self.val equals val, self.next equals next, self.prev is equal to prev. Great. We also want a way to represent this and print it out properly. So node is equal to self, vals is equal to empty, and let's reverse this because we want to both sides to look exactly the same. So while node vals dot append string of node dot val. So we're gonna append this string together, and previous is now equal to node, and node is equal to node dot next. So while this is happening, we'll move everything forward and keep everything in place. So with previous, we can now run file previous val reverse vals dot append string of node dot val. Not node dot val. So previous dot val. So previous equals previous dot previous. So we go both ways to make sure they're exactly the same. So now what we're gonna do is reverse vals should be equal to the reverse of vals. So they should be exactly the same if we double reverse it. So if they are not equal, then we should return 1 because they are not, we are not expecting that output. All right. So lastly, what we're gonna do is return the pointing system between 2 values, and we're gonna join them of all these values. So we're gonna have a the doubly pointing between the values. So let's make some linked lists and make sure that we're doing this properly. Let's do 1, 2, 3, and we're gonna test no object and 1 object, and so on and so forth, just to make sure that we are doing this properly. So let's create our testing. And let's write test. And let's say 1 is equal to linked list node at 1. 2 is linked list node at 2. 3 is linked list node at 3. And we're gonna make this, turn this into like a, let's say, we're just gonna do array equals 1, 2, 3. And we're gonna have to point these items to each other. So for I in the range of length stack minus 1, stack R, and R at I dot next is equal to R at I plus 1. And that's it for the pointing forward. Now we have to point in reverse. So in range, we're gonna start at R minus 1, and we're gonna go all the way down to 0, but not being 0, and that way R at I dot previous is equal to R at I minus 1. So with that, we should have a perfectly good linked list where we have are able to see whether or not this works. So that's all we're doing right now, just printing it out, making sure that our linked lists are good. We do need to make tests a little bit later, but let's run this first. Okay, it looks like we're printing this out properly. And now that means that our print statements work. That means our linked list is working. And yeah, we're doing good. So one thing to note is that I'm gonna just get some boilerplate code for my test, and this would be pretty quick, or I can type it out. So let's say I have items for I in a range of length test, and what we're gonna do is just print out the results of the test. So test at I plus 1. So this is our test here, number tests, and we're gonna say pass. Does it pass? And if it does, we're gonna set it to this particular output where test at I at this take the input of this dictionary is equal to the output. Perfect. So that's how we test our code. If it passed, then we have a pass, and if we don't, then we don't. So let's see what's going on here. Invalid syntax. So we can't do this, apparently, it seems. We can't do that, but maybe we can do this. How about that? Can we do this, please? Let's see. And that's a no-go. So what happens is that you do need to finish this off here and just print this as a separate, like, item. So, oh well, it is what it is. So we print it as a separate item. So that's good. So currently there are no tests, so there's nothing that should be printed, and we have our linked list. Currently we're at 18 minutes, and I think this has gone pretty long, and we will come back in part 2. I guess there will be 3 parts now. Part 1 is create linked list. Then part 2 is reverse a doubly linked list, and part 3 then reverse by pods. So we're doing part 1, create linked list, and part 2 will be to create the doubly linked list, reverse the doubly linked list, and lastly we're gonna do part 3, and we'll talk about that a little bit later. So I'll see you in the next video, and yeah. Should I do the outro? Probably should do the outro. So enjoyed the video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.